Gene finding, especially in prokaryotes, starts with finding ORFs or open reading frames. So let's see how we can define these open reading frames. ORF or open reading frame is a sequence of DNA, starts with ATG, and then it ends up with one of the three stop codons like TAA, TAG, and TGA. We also call them as termination codons. Here in this slide, we see the ORF in a comparison between a prokaryote and eukaryotic cells. Prokaryotes may be a bacteria or some related organisms. The rest of the organisms mostly they are classified in eukaryotes. So if you look into a prokaryotic situation, we have different genes which are separated by intergenic regions, and these ORF can be spanning these two genes. Whereas in case of the eukaryotes, we have just only one gene. We have exon 1 and 2, whereas the ORF spans across these different exons. So in the top part, we have longer ORF, and at the bottom part, we have relatively shorter as compared to the genome size, and those shorter ORF, which are actually spanning different exons. ORF provide important evidence in gene finding. Generally, we go for longer ORFs, but they are preferred, but these ORF may not actually translate into the proteins. Okay, so depending upon different start positions, we can define different ORFs. So if we want to go for those triplet codons, we can start with any nucleotide. So in this way, we have three different possibilities for one of the strands. And since we have two strands in the DNA, so total we can have six different, we call them reading frames or reading registers. So three on actually the forward strand, which runs 5 to 3. When you write a DNA strand, you write it 5 to 3 direction, so that we can call it as forward strand. And then there is a complementary strand, so that is, it runs actually 3 to 5. So here is how it looks like. So there are 6 frame translation. In this picture, we see that we have a top strand, which is the forward strand. So it starts 5 and ends at 3' end. The complementary runs anti-parallel fashion. So it starts with 3, ends with 5. So how can we can get these reading frames out of it? So we can start with position number 1 on the first strand. We label it as +1. So in this way we can start with A, and we can have triplet codons like ATG, GTT, GGG, and so on. In the second strand, or the second possibility is we can start from position number 2. So in this case, we give it a number as +2. So this frame goes like TGG, TTT, and so on. But sometime it can be starting from position number 3. It can be GGT, TTG, and so on. What if we start again from position number 4? It's no more different than position number 1. So there are these three possibilities of finding those reading frames on the top strand. Same way we can do the same thing from the bottom strand. And since this transcription starts from 5' to 3' end, so we will focus on this lower right corner. So that position we can call it as a -1 frame, or we can call -1 register. So it goes like AAT, TGT, CTT, and so on. Same way we have -2 starting from position number 2, and we can also have -3 starting from position number 3. So total there are 6 possibilities. If you get just a sequence of DNA, we normally write it as 5 to 3' end, but whenever we are doing gene finding, we take the reverse complement of it, and then we get all these 6 frames. So we try to get those ORF in all 6 frames. So that's we will observe in the gene finders also. So far in this section, what we have seen here is that ORF is a sequence of DNA that starts with ATG, and it ends with any of the stop codons. And there are 6 reading registers as far as finding those ORFs are concerned from a sequence.